Hello everyone, welcome back to week 6 stream processing. In this video, we are going to look into testing. We have already created a basic Kafka stream example for counting and also for join. And now we are going to basically write some unit tests for it. So let's see how to do testing. In our count and join example, we basically played with two classes from Kafka streams. Those were Kafka streams and a stream builder. The stream builder basically allowed us to say something like read from these two topics, maybe join on them or count on them, and then, for example, output it to another topic altogether. This whole process of the stream builder is basically what the Kafka streams object uses to start the stream basically. And on the Kafka streams, we say .start. And this process of defining inside the stream builder basically which topics to read from, what actually actions to take place, and where to output is basically called a topology. And this is exactly what we can test. So basically we can create a topology driver, which is basically in our test, and we can provide it this topology which we have built and we can test on it. But basically we have to create our code in a way that can return topology. And that topology can then be tested. So now let's write some code and let's see how this can be done. So now let's come back to our count example. In our count example, we saw that we started a stream builder. The stream builder basically read from a topic, did a count, and then output it to another topic. This builder was basically, the stream builder was basically then built and the topology was returned. And this topology was directly provided into Kafka Stream. So what we need to do now is to basically divide our code in such a way that topology can be extracted and we can test that. So let's do it. So what I will do is basically create a method which returns a topology. And let's call it create topology. And I will simply just copy paste this code and put it here. And basically in the end say return stream builder.build. Now this returns the topology which we are looking for. And over here I can say where topology is equal to create topology. So now what happened basically is that we have extracted out our main code. And this is the code which we would like to test also, right? We really don't want to test if kstream.start is working, if runtime.shutdown hook is working, because these things are already well tested, well defined. We don't want to really test it. Maybe we want to test our config. So it might make sense to have a test for config itself. Maybe, for example, if you want to make sure that nobody changes your cache max byte buffering config by mistake, then you want to do that. Similarly for auto offset, but not really needed. The main thing which we really want to test is our topology logic. And if anything is wrong in our topology logic, we would like that to be addressed. So the first thing I did was basically create a test class for this. I set up a skeleton. It's not doing anything special. It's just creating some of the objects we will need. And then it adds a before each method, which does which sets the property. And as you can see, it's just a test count config and some dummy bootstrap server. We really do not need to provide an actual bootstrap server. This is why it's a unit test and it's possible. So now let's first get our topology which we want. So for us, this would be coming from that topology is equal to new JSON Kafka stream dot create topology. Actually, we can also put this up here. So our topology is just read once. We don't have to read it every single time. So we created our topology. The next thing we need to do is basically create our test driver. So we already had a test driver here. And all I need to do is basically say our new topology test driver. Let's see. So it takes the topology and it takes the props which we have here. So the properties are passed. The test driver is basically there. And what we will like to do is now create the input topic. So input topic is equal to test driver dot create input topic. We can just name it. So for our test, or because it's rides, so let's name it rides, but put test there. Then we want, what do we want? So we want a key serializer, and that can come from our custom search. So let's do custom search dot get rides. No, because this is a key and our key is basically a string. So string dot serializer, and in our custom search dot get ride search dot serializer. So this is our input topic, and the output topic was basically, so rides count. Let's just name it that, like counts tests or test, whatever. Now we need a deserializer, and in this case, the deserializer would be string dot search dot string dot deserializer, and in this case it would be long, so search dot long dot deserializer. So now we have set up our dummy or test input and output topics. That's all we need to do in before each. Now let's actually write a test. So test public void test if one message input topic get count. So, or we can say, okay, I think this is good enough. So now I have also created a data generator helper class. This basically helps us generate some dummy rides and pick up location ones. And this is basically what I'm going to use. So I'm going to say, okay, ride is equal to data generator helper dot generate ride, and this generates a random ride for me. Okay, so now what I can do is basically input topic dot pipe input, and in this case it will be ride dot drop off location ID. So PO location ID, and because I have to pass a string, so I will just say string dot value of, and I need to pass the ride now, so I will just say ride. Perfect. So this is basically one input, and what we can assert is basically assert equals. So basically we will need assertions. Then we can say assert equals output topic dot. So get queue size should be 1 basically. So we should have at least one message in our output topic. Assert equals to output topic dot read key value. I think read key value would be here. So key value is equal to key value. Let's just see what I need to do. It's coming from streams key value. Okay. So key value, I think it should have starting with it. Dot pair. The key should again be our string dot value of ride dot do location ID, and the count should be basically 1. And then we can also say assert true that the output topic is basically empty. This is done just to be sure that the whole process runs successfully. Let's run it. The test fails. Unknown topic writes underscore tests. So the mistake we were making was basically in our topology itself, we also defined some input or output, and we need to use the same name. So it was rides and rides PU location test. So now I fixed that. Let's see. And the build is successful, the test is successful. That's exactly what we wanted. So let's try to do a test if 2 messages are passed with different key. So now let's create, so let's say this is ride 1. This would be basically ride 1. Then let's create the same thing, rides 2. Let's fix this actually. So let's say ride 1 dot drop off location ID is equal to 1L or 100L, and ride 2 dot drop off location ID is equal to 200L, just to make sure. And then if we do that, then we will find a read key value of with rides 1 geolocation as 1 because that's past 1, and then we will have rides 2 geolocation as also 1, and then it should be empty. Let's try this one. Oh, sorry. Let's try this one. And it creates empty topic, rides geolocation not. Oh yeah. Put topic.pipe ride 2. And it works. So now let's test our final case. Let's test what happens when 2 messages are passed with same key, basically. So same key, and in this case, this would also be 100. So 100, 100. And what do we expect is basically, what we expect is that actually we can change this. We can just say 100 here, just to be more static. And then we can say 100, but this value should be 2L, and then it should be empty. Okay, so this works, and this is exactly what we wanted. This might be weird for someone, but you need to imagine that as soon as a message comes in, the computation is done and the output is given to by the topology. Same happens in this case, and this is basically done because we have this cache buffering 0, and it's immediately producing rather than caching these values. But now we have tested these cases, and that basically completes our test for count. So what we can do is also create a test for our Kafka stream joins. So let's do that. Let's create a new test. I will just copy paste some code from here again. So we need all this again, basically. Okay, so this would be the input topics. Actually, it might be just better to new class of topics. Then we can take these here, move the private, make them public. But as they are final, nobody will be able to modify them. We can delete these things here and then just say that. Perfect. So now it should be fine. All right. Then we created a test. So in our test, we will just use the same ones again. We don't need any of these things. Let's copy paste this from our JSON tests. So this part, and we can also copy paste the input topic and output topics. So the input topic was also for rides. So let's name it rides or rides topic. And then let's create another one, which is for our pickup location. So string pickup location pick up location topic. What we need is basically a topology, so we will topology continue JSON string joins start create topology. So now we have our topology, you have our two topics, and what we need is create stop test driver dot create input topic, and this topic would come from topics dot input right topic. The serializer would be string, so search dot string dot serializer, and custom search dot write dot serializer. Then we will also need pickup location. Let's do that. And then we need the output topic topics dot output topic. So this would be again string, and the output would be a vendor info. So strings serializer. Let this be vendor. All right, that looks good. We need an after all, so we need to public void shut down. Need in this case is, I think we need to basically test driver dot close. All right. So set up which, so this would be the setup. Let's now write a test public void test if join works on same drop off pickup location ID. And what we can do is basically create a write. So write would be from our data generator helper dot get write, and then we can manipulate it a bit. So okay, maybe we manipulate it later. And what we can do here is we have our pickup location. So again, data generator dot pickup location. This would be basically the drop off location of our write. And what else do we need? That's it, I think. Cool. So writes topic dot pipe input. The string dot value of write dot tu location ID is our key, and then we have the write, and then we pick up location topic dot pipe input, and this would be string dot value of pickup location dot pu location ID, and then the pickup location itself. Great, so we have piped our output. Let's assert true or assert equals that the output topic dot queue get queue size is 1. So let's first test this. Let's see if this works. Okay, this works. Let's try to fail this test once. Yeah, it fails. So we know that it's working. And assert equals output topic dot get key topic present read key value is equal to basically key value dot pair. So what was our key stream joins? What was our key actually in this case? The key is coming from joint, and the key is basically the pickup location ID again. So string dot value of pickup location dot p location ID, and then this would be vendor info. So new vendor info. And what do we need for vendor info? We need the vendor ID, which comes from our rider. We need a pickup location ID, which comes from our pickup location. Then comes the local date time of the pickup, which also comes from pickup location dot pickup date time. And in the last, we need the last drop off, which comes from ride dot drop off date time. Let's do something like this here. Okay, let's try if this works. Okay, it's not. Okay, yeah, because vendor info is actually an object, so we might need to do something. All right, let's take this out. So let's say that expected is equal to this, where result is equal to this guy. Oh, sorry, this guy, and then we can say result dot key is equal to string dot value of site dot drop off location ID. Yeah, this should also be fine. And let's try to run this. Perfect. And then result equals result dot value vendor ID is equal to our expected dot vendor ID. So expected dot vendor ID. So even if this matches, I'm pretty sure that everything else will match. Yeah, it does. So then I can compare whatever I want to. Let's say pickup location time, and the pickup comes from pickup time, and this actually comes from pickup location PU location ID. So we also don't need to create this, but it's just easier to reason over it. So let's just run this. Yeah, it's running. Perfect. So now you can see that we can easily test our topologies using this methodology. And I would highly suggest you to write unit tests, whatever language you're using. Please do write unit tests and be sure that your topology is working. Thank you so much. See you in the next video.